Well, we're in the Mount Baker ski area near Mount Baker with Mount Shuckson in the background over here with this beautiful glacier on the top of it.
It's absolutely gorgeous. You don't see glaciers very often. They're kind of a unique thing, aren't they?
Well, you have to get up in the high mountains today in order to be able to see them. And they're much smaller than they used to be. Glaciers used to be much larger than this.
How big? Are we talking about just twice that size? Or?
In the past, glaciers have covered these mountains down even 3,000 feet lower than we have today. But even before that, ice sheets, which are basically glaciers on flat terrain, covered major areas of the world. For example, in North America, the ice sheets extended clear across Canada. They extended down into the United States. So that period of time when that much ice was here, that was the Ice Age.
Well, I think most people probably think if you just lower the temperature, you can get an ice age.
Well, it doesn't work that way because you got to get the water vapor from somewhere in order to produce the snow. So somewhere you have to have warm temperatures and you have to have cold temperatures. And we believe that's what happened during the Ice Age, that in the past that the oceans were much warmer and the continents were much colder, so that when water vapor that was evaporated out of the ocean was drifted over the cold continents, it then fell out as snow and ice.
As an atmospheric scientist, what do you see in the past that would have caused those unique conditions?
From my perspective, the Bible really gives us a clue as to what happened that caused the Ice Age. The Genesis flood was a magnificent, catastrophic, high-energy event, and it left the oceans warm. And it took about 1,000 years for the ocean to cool back down to the temperature that we have today, where it's uniform. But during that period of time, particularly right after the Genesis flood, when the oceans were the warmest, it produced a tremendous amount of heat and evaporated water into the atmosphere, which then fell as the snow and the ice on the continents, forming the Ice Age. So the Genesis flood was actually the cause of the Ice Age.
Larry, that sounds like we have some very, very unique conditions then.
Yes, they were. For example, we know that there were a lot of activity in the ocean. The plates that we are aware of on the surface of the earth today, between those plates there were cracks where magma came up, hot magma from the mantle, spewed out on the bottom of the oceans and formed a gigantic mountain chain. And that 40,000 mile long mountain chain of hot magma, as it cooled, warmed up the ocean. And we have that information from estimates of sea surface temperature from seafloor sediment data. And the conventional community believes that as well. It's just they have a different age for it, 65 to 100 million years ago during the Cretaceous period when it was that warm. And that would have produced a tremendous amount of evaporation, which then drifted over the cold continents. Now, the continents, we believe, were cold because of volcanic dust and material being lofted into the atmosphere, into the stratosphere, a high atmosphere, which blocked off the solar radiation coming in and warming the continents. And it kept it cold so that you had the warm oceans, the cold continents, therefore you had lots of water vapor evaporating and being converted into snow and ice to form the ice sheets and glaciers on the continents.
So all that warm water and the cold continents over a long period of time then produced those very, very huge ice sheets you were talking about.
In fact, some of the modeling work I've done using conventional models but with a very warm ocean produced precipitation rates that would have produced ice sheets and glaciers 5,000 to 6,000 feet thick in a matter of 500 years or less. And it may have taken another 300 or so years for them to melt back at the end of the Ice Age. Now, the intensity of this occurred around the time of Job. That's why when you look in the Bible, you don't find any reference to the Ice Age, but you hear Job, he says, out of whose womb came the ice. So in the area around Israel, for example, the most likely place that he would have seen snow would have been on Mount Hermon. Now there's ice and snow up there occasionally in the wintertime there, but it doesn't extend down very far and it doesn't last very long. But during the Ice Age, it may have been that Mount Hermon had a permanent glacier on it.
So this is the age of Abraham as well.
Well, just even in Israel, we think of it as strictly a desert like we see there today.
Sure.
But there's evidence that in the past it was a much more moist, wetter environment. In fact, I have found that the precipitation may have been as much as 3 or 4 times what it is today back during the time of Job and Abraham, and that whole country may have been moist and green. You know, the Bible talks about the land of Israel being a land flowing with milk and honey. The Jordan River Valley was green all the way down to the Dead Sea. So it's just amazing what a warm ocean and cold continents will do in a very short period of time.
All of this brings up some interesting things, like the woolly mammoth that's frozen, maybe even has buttercups in its mouth. How does that fit into all of this?
Well, the conjecture is that many of them were up in the northern part of Siberia, which was south of the Arctic Ocean. It's likely that the Arctic Ocean was warm as all the other oceans were, and it would have taken maybe 500 years for the Arctic Ocean to finally freeze over. And at that point, then you begin to accumulate the snow and the ice. Right near the Arctic Ocean, it was maintained a relatively warm climate, so they would have been able to stay there and repopulate the Earth. But during that time, the snow and ice further south, which would have been colder, further inland from the Arctic, and kind of formed a barrier where they couldn't escape. And eventually, when the Arctic froze over, then the whole climate changed, and then they were frozen. Now, why they ended up with fresh buttercups in their mouth is quite a mystery. And that implies that near that warm climate of the Arctic Ocean, you could have had vegetation that could have grown. They could have eaten that, and then suddenly there would have been a really strong storm of some kind, or a series. The weather changed rather dramatically when the Arctic suddenly froze solid, and they were frozen.
So we're back again to another catastrophic event.
Well, the world was continuing to change rather dramatically, continually, as the Ice Age developed and then eventually came to its maximum and then began to melt back again. During that time, people were moving over the whole surface of the Earth. The ocean levels were changing, the climate was changing. Slowly, volcanoes and earthquakes and all those began to decrease in intensity. So there was a tremendous dynamic going on for 1,000 years or more after the Genesis flood.
Well, there is a lot of talk about climate change today. How does that fit into what you understand?
Well, some people are concerned that we may be going back into another ice age. And this really it helps us to understand why some people are so concerned about a short period of global warming or cooling. There's a viewpoint within the community of paleoclimatologists, these are people who study old climates, that just before an ice age starts, they believe that there's an instability, so that the climate gets very warm and then it gets very cold and it's oscillating. And so they see the climate as very unstable, very sensitive to small changes. So that if we put in pollution in the atmosphere, the particulates or gases, and possibly contribute to some instability, that it will suddenly go to an ice age. As a young Earth creationist, I believe that the atmosphere and climate is very stable. In fact, it took a major catastrophic event like the Genesis flood to kick off the climate change that we saw that produced the ice age. So that's why there's a major difference in viewpoint between different people about how unstable or stable the climate is. We would basically say there was only one ice age following the Genesis flood, not multiple ice ages or up to 60 different ice ages. These are derived primarily from seafloor sediment data. Ice cores don't show that many, but they interpret the wiggles in the temperature estimates from the seafloor sediment to get these many ice ages. But even those have major problems because the seafloor sediment that is looked at is on the order of 20, 30 meters or 60 to 100 feet of sediment. And you're trying to interpret multiple ice ages that occurred over millions of years from layers that are on the order of less than a millimeter thick. And it's almost impossible to interpret it that way. So there's a real challenge to justifying more than one ice age.
Looking at this from then the conventional paradigm, how do they come up with the means by which an ice age can occur? You were saying an ice age requires some very unique conditions.
Generally accepted conventional explanation for the ice ages is something called the Milankovitch or the astronomical theory. And it was developed back in the 1970s. based upon a hypothesized correlation between the way in which the Earth orbited around the sun in an ellipse, and it goes into a circle and then back to an ellipse, or the Earth's orbit wobbling slightly, or the Earth's position in this ellipse going around the sun. It's hypothesized that this correlation results in about a 20,000 or a 40,000 or a 100,000 year period between ice ages. And that's been the generally accepted idea of what causes the ice ages. But there's several major problems with that model. One is that the 100,000 year period is the one that's generally accepted as the period of the ice ages, and that's the weakest correlation with the seafloor sediment data. So therefore they have to suggest some kind of a feedback mechanism or some way to make this weak signal amplified so it produces the ice age. So they suggested this idea, and they call that the pacemaker of the ice ages. Kind of like the heart pacemaker, you know, it's just slight electrical impulse to cause the heart to beat. So they're suggesting that the one orbit that's about a 100,000 year period has enough, just a little bit of an energy to cause that ice age to begin and then end in 100,000 years. But they don't know what that physical process is that amplifies that signal. So it's a very weak argument. There's not enough energy to explain how you get the cooling you needed to occur all year round. There's been a lot of modeling, for example, attempted on explaining the ice ages in a uniformitarian viewpoint, and there's not been any success in being able to explain an ice age with this uniformitarian viewpoint.
So again, the conventional paradigm seeks to understand all of that through current processes. We have almost natural events going on that create ice age after ice age, as opposed to what you're saying, and that is that if you're going to get an ice age, you have to have some really, really catastrophic events and some very unique conditions.
Very high energy events in order to be able to cause the atmosphere to react the way it did.
Yeah. Well, Larry, that brings us to an issue that a lot of people have, has to do with ice cores and the dating associated with those ice cores. What has your study shown?
Well, first of all, ice cores are made generally in Greenland and Antarctica. That's where they come from. It's a very large amount of ice there, and it's basically maintained itself the whole time. The cores are taken by drilling about a 6-inch to 8-inch core down through the ice, drilling down all the way down to bedrock at the bottom and pulling them out very gently, maintaining them in cold conditions so they're preserved. And then you look at the detail in the ice through that long length. The ones from Greenland are about 4,000 to 5,000 feet long. The ones in Antarctica up to 9,000 feet long. And in there you have visual layers that you can look at that were formed as the ice compacted and went from snow to ice, and it maintained the bubbles that are in there. It has various chemicals that are in there, dust layers that are in there, looking at oxygen 18 isotope ratios. From all of those various features, you can see the variation with time down through the ice core as it accumulated material. For one thing is that you would expect there to be one ice age following the Genesis flood. And you see that in the record. Where most of the evidence is presented that there were multiple ice ages is at the very bottom of the core, where it's the hardest to interpret. And it shows that it was disturbed very strongly down at the bottom of the core, as well as the fact that there was all kinds of dust and chemicals and features that you have a very difficult time trying to interpret. If, in fact, the Genesis flood was caused by a catastrophic event, and it produced all kinds of volcanic eruptions and the Earth's surface being disturbed greatly, you would expect to see that at the bottom of the core, and that's exactly what you find. And it's not just a small, thin layer down there, it's up through quite a depth through at the bottom of the core. So that fits very naturally with the Genesis flood idea with the catastrophic process that occurred there. Now, there's also some question that's often brought up about the formation of ice in Greenland, for example, and how that accumulated. There was a recent incident that occurred at the end of the Second World War, which is quite fascinating. There was a squadron of P-38s and a couple of B-17s that were flying from North America over to England at the end of the war. And that was over 50 years ago now. And they got stranded out in the middle of the North Atlantic, so they ended up crash landing on the southern coast of Greenland. But they were rescued about a week later. But the planes were left behind. And there was a wealthy Texan who decided to go looking for these planes because they were very valuable to restore, particularly the P-38s. So they went looking for the planes on the southern coast of Greenland, and they couldn't find them for about a year because they had moved. The ice was slowly drifting toward the Atlantic and calving off and disappearing. But they looked about 10 miles from where they knew they had crash landed and found them 250 feet down in the ice. What had happened was the average precipitation that occurred on the southern coast of Greenland was an average of about 5 feet of ice per year, solid ice, that accumulated. So in 50 years, you got about 250 feet of ice above the airplane. So they were buried down there. Now, what's that got to do with the Ice Age? The importance of this was, how do you get that kind of accumulation of ice in Greenland in that short of time? The normal amount of ice that accumulates in Greenland is less than a foot a year, typically in Greenland. But on the southern coast of Greenland, where those planes happened to have landed, was where the Gulf Stream intersects with Greenland, which is a warm ocean current that comes up the east coast of North America and is a large source of water vapor off the coast of this cold continent, very much like what we've talked about globally. So this is a small scale event that would produce an increase, a 5-fold increase in the amount of precipitation in just that southern part of Greenland and accumulate that amount of ice.
And those are the unique conditions you were saying were required.
But it was globally. It was global instead of just this little local area. So it's very, very convincing.
A lot of people think that you can just count those layers in the ice core like we count tree rings. Is that true or not true?
In the upper part of the core, you can count the layers. But when you get down further, where they've thinned so greatly, and there's such an incredible difficulty in interpreting all the various information, you cannot count them as individual rings, particularly visually. And even the chemical compositions and the oxygen 18-16 ratios and so on, there's a tremendous controversy on that. So basically, you can estimate it for one ice age, but it doesn't go back to hundreds of thousands of years, and you cannot count them as annual layers. There's too much difficulty in interpreting the record.
So it seems we have some real differences in the assumptions associated with how we count those layers.
Well, if you had a considerable amount of precipitation following the Genesis flood, you would have had a lot more precipitation than is normally assumed. Down in the middle of the core, things get so thin that you can't really interpret it correctly. The amplitude from the oxygen 18-16 ratios are almost impossible to interpret in terms of annual layers. And in fact, these layers can be easily interpreted as storm layers, not annual layers. So that if you assume that, say you had a storm every 3 days, you would have 120 of those layers in 1 year, not just one layer. And so these interpretations are very inaccurate. And so you can't assume that in each individual layer is an annual layer. It's not hundreds of thousands of years. It could be just a few thousand years.
You love this work, don't you?
Oh, I've done it for years, yes. That's why I got into it. I love atmospheric science.
This is the kind of thing that I would hope that young people would begin to see, that this is a frontier for them.
Well, that's one of the reasons I got into it. When you work in conventional science, typically you don't get to ask the big questions. But as a creationist, I'm able to ask questions that nobody else is asking because I'm looking at what the Bible is saying and applying the Bible to my science and asking questions that are actually surprising when you find the answers that you get from your research. It's exciting to be able to do that sort of thing.